Hello friends, in this session we are going to discuss an example of associative mapping technique. So as discussed earlier, because of the disadvantage of high conflict miss in case of direct mapping technique, the associative mapping technique was introduced. So in this session I'm going to discuss an example with the help of a question of the associative mapping technique. Let's start with it. The question is, a 128 line 16 word cache is provided with a 64 kilowords main memory configuration of a system. What are the tag and word bits for performing associative mapping? Right. So first of all, let's jot down the given things in the question. We have the number of cache blocks as 128. So this 128 line basically means the blocks. So there are 128 blocks in cache in which each block actually has a size of 16 words. So size of one block is 16 words. And also we've been given with the size of main memory, which is 64 kilowords. Then the next question is, what are the number of blocks in main memory? So the number of blocks in main memory is equals to 64 kilowords, which is the size of the main memory, divided by size of one block, which is 16 words. And we get, when we simplify this, since 1 kiloword is 2 to the power 10 words, so when we simplify this, we get to know that this is 2 to the power 12. Fine. Now we discuss the direct mapping, we discuss the associative mapping techniques format. So it is, the representation is that we have the tag bits, word bits and the total bits over here. The total bits basically represent the total bits required to represent your main memory size. So since the main memory size is 64 kilowords, so if I have to find the number of bits, the total bits, it will be total number of bits required to represent main memory, which will be equal to log 2 of size of main memory. Now this is equals to, if I simplify this, this comes out to be 16. And the tag bits, what are the tag bits now? The tag bits are the number of bits required to represent the blocks of main memory. That means I need to find the number of blocks in main memory first. So that we've already found, which is 2 to the power 12. So that means tag bits will be log 2 of number of blocks in main memory, which is log 2 of 2 to the power 12. Now this comes out to be 12, right? Because of the log property, that this is actually equals to 12 log 2. Now a number with the same base has log equals to 1. So 12.1. 12.1. So this is equals to 12, which I've written over here. Right? And next, when we find the word bits, now word bits will be equals to log 2 of size of one block, because word bits represent the number of bits required to represent a block. So the word bits equals to log 2 of size of one block, which is equals to log 2 of 16 words, which is equals to log 2 of 2 to the power 4, which is equals to 4. So therefore the associative mapping techniques representation is this. We had to find the tag bits and the word bits. So the tag bits are 12 and word bits are 4. So that's all for this question. I'll also be posting some more questions on the mapping techniques as requested by many viewers. And I'll also try to include some of the gate questions shortly. So stay tuned for some more good work coming up. Thank you, friends.